liftoff of the Delta rocket carrying GLAST.
All right. Good morning, everybody. My name is Sebastian Martinez. I am with Big Brothers, Big Sisters of Central New Mexico. We are very, 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 very excited. Lots of varies there to begin kicking off our Discovery Festival 2022 event. This is the virtual portion of the event. We will actually be having our live exhibits this Friday at Expo New Mexico. So I encourage you all to attend. Along with the very, very excited about Discovery Festival, but we're also very, very excited to have Amazon here with us today. They're going to be sharing some information about what they do. And I would like to introduce Nicole Ramos with Amazon, who is your host today. Nicole, welcome. And thank you very much for participating in Discovery Fest. And it's all yours.
Thank you so much, Sebastian. Thank you, Big Brothers, Big Sisters, New Mexico. I am so excited to be here. Woo! I can't wait to hear from all of you in the chat in just a minute, but I want to introduce myself a little more. I'm Nicole Ramos. I work at Amazon. I work with a team called Amazon Future Engineer, and my team exists to help young people like yourselves learn about and get excited about future careers and career possibilities that intersect with computer science. So I'm going to take you on a virtual tour today of our Amazon fulfillment centers. All right, and we're going to get started. I'm going to share my screen, and it's going to be an interactive tour. So at some point, I'm going to ask you questions, and I hope to hear from some of you in the chat. So teachers, if you're showing this in your classroom, you may have to be the scribe and ask students to shout out answers and just put in what you can. You may have to facilitate a little vote if it's a multiple choice question, and just do your best to throw some answers my way so that we can keep this as interactive and fun as possible. All right, here we go. Hopefully everyone can see my screen. We're off.
Everyone. Welcome to your Amazon Future Engineer Robotic Fulfillment Center tour. My name is Kia and I'm an area manager at BFI4, the Amazon Fulfillment Center in Kent, Washington. On this tour, you will discover how computer science, state-of-the-art engineering, and incredible people deliver customer orders at Amazon. Today, you're going to tour a few of Amazon's robotic fulfillment centers, or as we call them for short, FCs, where people and robots work together to pick, pack, and ship items to our customers. Our fulfillment network includes more than 200 robotics facilities around the globe. But before we begin, I want to know what you may already know. After a customer clicks order on Amazon.com, what do you think happens next?
Oh goodness, I think I've restarted it. Hang on, y'all. Let me get out of our full screen here. All right, so just take a moment here, and I'm curious in the chat, what do you already know about computer science, about robotics, and or about how Amazon fills orders so quickly? Be super curious for you just to share with us. All right, so awesome. Wondering what kind of words come to mind when you think about computer science? Ooh, Blockly and Scratch. So we know some stuff about code. Very cool. That is related to computer science. People and robots work with each other. Ooh, you are nailing the theme of this tour. Very nice. Okay, I'm going to get back on to the next part of our tour here. Get to this. Here we go.
This tour will travel through each stop of the fulfillment process: the robotic field, pick, pack, slam, and ship. And bonus, at the end of our tour, you'll meet 3 of the many engineers who make this technology possible. To help us on our journey, I have a few friends that have agreed to join me, and you will meet them out on the FC floor.
Hey everyone, my name is Trinidad, and I'm from San Marcos, Texas.
Hey everyone, I'm Kate from Robbinsville, New Jersey.
I'm Tony from Minnesota.
Hey everyone, I'm Pat coming to you from Miami, Florida.
Before we begin, a few things to know. At each stop of the tour, there will be a trivia question to see what you may already know. You will also be introduced to some computer science vocabulary along the way. Make sure to take some notes in your note catcher. Now, let's start with our first trivia question. Are you ready for some fun? What do you think was the shortest recorded Amazon delivery from the customer clicking buy to the order being in their hand?
All right, what do you all think? What is the shortest recorded Amazon delivery from the time someone clicked buy on our website until the order arrived? We've got some fun trivia music. Do you all think it was under 3 minutes, under 30 minutes, about an hour, or about 3 hours? Okay, got some guesses coming. Someone's got it. Whoa. 30 minutes. It was under 30 minutes. That is really, really fast, right? I'm going to turn our volume back up and learn about how that happens so quickly.
The correct answer is under 30 minutes. That's incredibly fast. Our average time is around 24 hours. So how does Amazon deliver customer orders so fast? The answer has to do with algorithms. What is an algorithm? Let's find out.
Algorithm, a set of instructions or rules that a computer follows to perform a task.
So after someone orders, it's an algorithm that assigns the order to the closest FC. But what happens next? Well, it's time for the first stop on our tour, where you'll meet my friend Trin in Texas and see some robots in action.
At Amazon, people and robots make an amazing team, working together to get products to customers as quickly as possible. Welcome to stop number 1, the robotic field. Behind me, you can see our robots in action. And we currently have two sizes of robots here. A large unit that's 750 pounds and a smaller one that's 325 pounds. We call them both drives just to keep things simple. Now, as well as the drive units you see whizzing around the floor, you'll also notice the yellow pods that the drive units are picking up and moving around. Now, they do this using a powerful hydraulic lift. These pods are mobile shelves which store some of the items that we sell on our website. Our drive units are small, but they are incredibly strong. They have enough mechanical muscle to lift a staggering 1,500 pounds. They could literally lift a cow if you had one that you wanted moving and asked them nicely. They use a combination of wheels and electric motors to move and sensors to navigate their surroundings. They also tell us exactly where they are on the floor, or as we call it, the robotic field. The robots are in charge of getting the correct pod with the customer's items on it and bringing it to the picking station. Now, this is much faster than having to walk from shelf to shelf. Before we continue, we've got a trivia question. How do you think Amazon arranges these items in the warehouse and in the pods to stay organized?
All right, good question for us. So in the chat, I'd love to see, how do you think that the robots find our items in the warehouse? How are they organized? So here we go. Let me get us to the trivia question. So quiz. How are these items arranged in the warehouse so that the robots can find them? Randomly? By their purpose? Like in a store, all the grocery items together, cleaning supplies, all the sports items together, clothing together. Is it by color? Is it alphabetically? First guess in the chat. If it comes in the next 10 seconds, I will click in it and see if you get it right. Who thinks it's alphabetically? It's not. It's random. Can you believe that Amazon just keeps all of the items randomly in the warehouse? They're not organized in any particular way at all. I thought that was so surprising when I first learned that.
Believe it or not, items in the FC are stored randomly. Now, we've discovered that since the computer knows where every item is, it doesn't matter where they are stored. In fact, it's faster to have items spread out than in one spot. For example, if 100 people ordered the same toothpaste and it was all stored in the same pod, then all the robots would have to go to that same pod and it'd be a traffic jam nightmare. Instead, an algorithm tells the robot which pod to go to because many could have the correct item. The algorithm picks the closest available pod. So how does a robot know which pod to go to? Let's dive deeper with a video.
After a customer completes their purchase, the order is processed in the Amazon Web Services Cloud Computing Network. Cloud computing allows us to deliver technology resources like computing, data storage, networking, and intelligence through the internet. We simply call it the cloud for short. After assigning a customer order to a fulfillment center, we need to determine where the item is stored. Inside the FC, items are stored in tall, movable shelves called pods. Since items are stored randomly, the item may be stored in more than one pod. A drive unit will eventually deliver one of these pods to a picking station where an associate will pick the item off for packing. An algorithm in the cloud calculates the most efficient combination of picker, pod, and drive unit to process each customer order. But how do we keep track of all the robots? The FC floor is a grid system, and each square has a unique QR code. As the drive unit moves, the robot uses a camera sensor underneath it to constantly scan and update its new location in the cloud. This combination of real-time sensing and cloud processing allows the drive units to work together to clear paths for each other and fulfill orders as efficiently as possible.
So you now know how robots navigate the robotic field to retrieve items. But what happens if something goes wrong? Well, if an item has fallen off of a pod, rather than driving into that fallen item, the robots will instead recalculate their journey to avoid that obstacle. This information is then sent to the cloud, where it is shared with the other robots and maintenance teams in the FC. Now, we also have a crew of technicians and engineers who can fix any drive unit in distress, providing any required maintenance and getting them back on the grid and doing what they do best. To keep those employees safe while they roam the robotic field, they wear an awesome tech vest that looks like something straight out of a video game. The tech enters the robotic floor with this vest on, and that vest sends out a radio signal to each drive unit, causing them to slow to a complete stop when a human is present in their vicinity, kind of like a force field around the technician. So now we've seen how robots work and how humans troubleshoot any issues that occur on the robotic field. Well, what happens after the robot successfully retrieves a pod? Well, let's head over to stop number 2, the picking process, to find out.
Hey everyone, it's Kate again. Welcome to stop number 2. This is pick. You may be wondering, once the drive unit has the pod, what happens next? It carries it to the picker's workstation. The picker has a screen in front of them, a scanner, and a collection of plastic boxes that we call totes. When a pod arrives, a light shines on the compartment that the desired item is stored in. This helps our picker locate the exact item they need. We give them more information on the screen, including the product's name, type, and a picture. A scanner is positioned above the station to scan the items. Once the item is found, its barcode is scanned using that overhead scanner to confirm that the picker has selected the correct item. The item is then placed into the tote with the green light above it, and we simply tap the sensor as we place the item in. Now that the item is in the tote, we can send it to our packing area. We do this by sending the tote along a conveyor system. Trivia question time. How many miles of conveyor belt do you think are in the EWR4 Fulfillment Center in Robbinsville, New Jersey?
All right, we're getting to almost one of my favorite parts. So let's do another trivia question. How many miles of conveyor belt do you think are in the fulfillment center in New Jersey? You could just think about fulfillment centers in general. 5 miles, 10 miles, 20 miles, or 30 miles? Feel free to drop your guesses in the chat. Who thinks it's 5 miles? Do you think it's 10? 20? Do you think there could be 30 miles of conveyor belt? I'm gonna click it and see what happens. Yay! I haven't been following our leaderboard, to be honest, because we've been running out of time on a lot of our answers. This is a Kahoot, so we're playing against other classrooms, really. We'll take a look at how we're doing. We're cute, Emu. All right, let's find out a little bit more about these awesome conveyor belts.
Can you believe that we have 30 miles of conveyor belts in EWR4? The totes ride these belts like a roller coaster, allowing us to move huge amounts of products without needing to lift a finger. Well, you've done such a great job listening so far, everyone. You have certainly earned your tickets to packing. Now, I am going to shrink you down to fit inside one of these totes behind me, and you're gonna take a ride on a conveyor belt. Remember to keep your arms and legs inside the tote at all times and show your ticket to Tony on the other side.
Hello again, everybody. How was your ride? Not too fast, I hope. Everything where it should be? Well, fantastic. Welcome to stop number 3. This is pack. Now that the items have been picked off by our robot picker wonder team and placed into the totes, it's time to pack those items into our famous Smile boxes. But before we start, it's time for another trivia question to see how you think the pack process works. How does a packer choose the most efficient box for packing?
All right, I'm curious what you all think. We haven't given you the answer on this one. So just think about it. How do you think a packer might choose the best box for packing? Is it because they have years of experience training with experts at our packing dojo? Is it because they follow on-screen commands based on previously recorded item measurements? Do they just simply use the rulers and tape measures on each item and do the math and figure out which box is best? Or do they just kind of eyeball it or look and see which box looks like the right size? Yeah, the answer is they follow on-screen commands based on previously recorded item measurements. Sorry, I brought us back down here. I've got to start answering our trivia questions. I'm not being fair to you all in your classrooms listening in on this. Here we go. Oh, just kidding.
And those on-screen commands are based on item data. But let me tell you the how and the why we do this. Amazon sends out a lot of packages, and we have a responsibility to ensure everything in our power to limit our impact on the environment. So we try to be as efficient as possible by using as little time, electricity, cardboard, gasoline, and still delivering effectively for our customers. We need to make sure that we're doing everything in our power when shipping our customer orders in the smallest box possible. But how do we do that? When a book, a game, or a garden hose arrives at a fulfillment center to be sold, we record a lot of facts about it, like its height, its width, and its weight. Now these facts are stored in a database. But what's a database? Let's define it.
Database. An organized collection of structured information, or data, typically stored electronically in a computer system.
So when you click buy on Amazon.com, our systems will reference the item's dimensions from the database and automatically calculates, using an algorithm, which box is best, even if it's combined with many items. So how does this happen at a pack station? How do we actually get customer orders in a box? Well, we grab a tote and we scan the barcode on its side. This tells our system that the products have arrived at pack. The packer then grabs one of the items, checks it, and scans it into the computer system. Next, the computer tells the packer what size box to use, and it's the smallest box possible. The system knows because the item's dimensions are already in the database. When the item barcode is scanned, the computer automatically spits out the exact amount of tape needed. The packer then uses air pillows to secure any loose items to make sure that nothing gets damaged. Then the box gets sealed. Last, we add a special label to tie the virtual customer information to the physical box for the first time. This special label is a barcode, and it acts as an identifier, kind of like a license plate for a car. You see, we don't actually place the customer details on the box quite yet. The packer doesn't even know where it's headed to. And customer privacy protection is very important at Amazon. The package is now going onto the conveyor belt, joining all the other packages that our team of packers have assembled. Now, do you remember the last thing the packer did in the box? They placed the package on the conveyor belt, and this conveyor belt is heading to our next area called SLAM. So, that's all for packing. Let's head over to SLAM.
Welcome. Here, we are going to cover stop number 4, SLAM. Before we start, you know the drill. It's time for another trivia question. At SLAM, we check to make sure each box item is correct. How do you think we do this?
All right, what do y'all think? How do they check that the items are correct in the box? Do they weigh the item? Do they use an X-ray to check that everything inside the box is correct? Is there a robotic arm that picks it up and shakes it and listens for the right sound? It doesn't perform any more tricks. You're trying to check us. We already know the order's right. What do you think? Are we tricking you? Or do we do a final check in one of these other ways? Oh, it weighs the item as it goes over the conveyor belt. I got us some points this time. I got to be fast on my clicking on this quiz. All right, thank y'all for your answers in the chat. Let's keep going. Ooh, we're moving up the leaderboard. Cute emo. Cute emu, looking cute. Here we go.
Did you get it right? Before items ship to customers, we weigh the box to make sure everything is correct. This is an example of quality control.
Quality control, a process used to ensure that a product or service is free from error.
After items are packed, boxes head to the SLAM station for quality control. SLAM is an acronym that stands for Scan, Label, Apply, and Manifest. Here, a camera sensor reads the box's special label to identify the customer's order. This tells the computer what items should be in the box. Then, our system looks up each item's expected weight from our database. An algorithm adds all the expected item weights together, plus the weight of the box, to calculate the total expected order weight. Thanks to computer science, all this math happens almost instantly after the special label is scanned. As the box continues down the conveyor belt, it is weighed using a hidden scale. Our system compares the actual package weight with the expected package weight to see if the two weights match. If they match, we assume the order is correct and the package heads to shipping. But what if the weights don't match? If the weights don't match, this could signal that the order is missing an item or has an incorrect item. The SLAM machine automatically pushes the box off the conveyor to be inspected and corrected by an Amazon employee. This quality control process ensures that orders are correct and prevents incorrect orders from leaving the FC. Finally, the shipping label, complete with the customer's name and address, is printed and applied onto the box using a robotic arm, SLAM. As you can see, and as the name suggests, the arm slams down onto the box and applies the label. Well, actually, with the help of a sensor, the robotic arm stops just before touching it, and a blast of air from a tiny hose blows the label the rest of the way. This avoids any injury to the box. And with that, the package is ready for shipping. Now it's time for our final stop, ship. So, final trivia question. How do you think our packages are organized when loading? Afterwards, we'll send it over to Patrick to tell you the answer at the last stop.
All right, another fun trivia question for you all. How are the boxes organized when they're loading? Love to see your guesses in the chat, classrooms. Random, just like we do for our storage of items. Turn this music down. Is it the robotic arms pick up each item and sort them into trucks? Are the packages pre-sorted using high-tech conveyor system? Or are the packages sorted by hand? Employees read the address and figure out which ones are going to the same area. Right, good guesses, y'all. Packages are pre-sorted using the conveyor system. I think it's amazing how fast all of this stuff happens. I hope you all are surprised too. I can't believe that with computer science and robots and these conveyors and sensors and algorithms, that just as a package is moving down the conveyor, it can get weighed and checked against the database to make sure that it's the correct item. Just astounding. All right, let's move on. All right, we're number 26 in our rankings. Let's see how we can do. Here we go.
Yes, small packages are pre-sorted using our high-tech conveyor system. So, welcome to stop number 5. ship. Right outside the building, there is a line of trucks waiting to be loaded. So how do we get the packages to the trucks? And how do we decide what truck they should go on? Let's take a look. First, we use our conveyor system to send packages from the SLAM station to our shipping sorter. When they arrive here, the shipping sorter uses a sensor to scan each box and determine its final destination. The sorter then uses an algorithm to assign the packages to the truck that will provide the fastest delivery route. And the craziest part is, this happens almost instantly due to computer science. After the system scans and virtually assigns a box to a truck, the box continues down the conveyor belt. When the packages reach the chute for its assigned truck, the system triggers these blocks, which you see on my left, to push the packages off the conveyor and down a spiral chute to the loading area. Packages will then be loaded on a truck. Once the truck is full, it departs for a sort center or delivery station, where the packages will be sorted and loaded onto smaller Amazon vans. It would not be very efficient to have those big semi-trucks driving around your neighborhood. So the final miles of delivery are completed by these small vans. In order to plan the best delivery routes, we need the best maps. Amazon uses a very special type of technology called machine learning to create these maps. What's machine learning? Let's find out.
All around the world, humans are constantly constructing new buildings and roads. So how does Amazon keep its maps updated to deliver to even the newest locations? The answer? Machine learning. Machine learning is the science of teaching computers to perform or make predictions based on examples or past experience. To keep our maps up to date, we train computers to use satellite images to detect new roads and buildings on their own. Computers can learn? Yes, but it depends on how well they're trained. To train a computer to detect new roads, we show it thousands of examples of satellite images to compare to existing maps. The computer learns what roads and houses usually look like, and then creates its own road detection algorithm. It uses this algorithm to find and predict roads on new satellite images. Machine learning enables us to process way more data than would ever be possible on our own.
Now, machine learning isn't just used to create great routes for delivery. We actually use it in all of our process to help us deliver packages more efficiently. For example, this shipping sorter will speed up and slow down according to the volume of packages riding on it. There are many more exciting innovations that will keep us delivering efficiently in the future. Amazon founded the Climate Pledge in 2019 and commits to being net carbon neutral by 2040. So, we need to be carbon neutral in shipping as well. As part of working toward this goal, we ordered 100,000 custom-built electric delivery vehicles, some of which are already being used to deliver orders today. These vehicles are expected to save 4 million metric tons of carbon per year by 2030. Pretty impressive, huh? I bet when the next time Amazon package shows up at your doorstep, you'll be able to wow your household with your knowledge on how this order arrived. Now, I'm going to hand it back to our host. See you later.
Welcome back. How was your tour? Today you saw how computer science and people make a great team. Before we head to meet the incredible engineers that make this technology possible, let's take a second to reflect on what you've seen so far.
All right, this is just a moment. We have just seen a lot, heard a lot, learned a lot about how Amazon orders are fulfilled. We've learned about robots and algorithms, some of the software and hardware, and we learned everything from how orders are picked to packed to shipped. So just take a moment here, and if you're using something to take notes, you could write it down. If you're with classmates in the class, teachers, maybe you could facilitate a quick turn and talk. Or if you're just on your own, just take a moment to think, right? Here we go. What is it that you've learned so far? What is the most surprising part of the process? I'll give you just another few seconds to jot down your thoughts or share your thoughts with a friend. All right. So awesome. I know you've learned at least one cool new thing, if not many cool new things. I'm going to show you a video now where you're going to meet some of the engineers who worked on the technology used to help all of the pieces of that Amazon fulfillment system. You also get to meet me. I'm here. I'm Nicole. I work at Amazon, and my job is actually a product manager. So I work with engineers and with a lot of other people to help Amazon build products or new software or new hardware. But I happen to work in Amazon Future Engineer. So we build education products and software. All right, let's meet some of my amazing colleagues, some of my favorite people that I get to work with.
So, you may be wondering, who invented all this stuff? And the truth is, it's people like you and me. There are many different types of engineering careers at Amazon. Let's meet 3 of the engineers responsible for the technology you saw today.
My name is Erica, and I'm a research scientist at Amazon Robotics focused on hardware.
My name is Rohit Raman, and I am a software development manager here at Amazon Robotics.
My name is Julie Mitchell, and I manage the Solutions Design team at Amazon Robotics. In Solutions, we take different building blocks made up of hardware and software that come together to form a system. That system does complex tasks like picking, packaging, and shipping Amazon's orders to our customers. I am from just outside of Boston, Massachusetts.
I am from Mumbai, India.
I'm from Nigeria and Dubai, UAE.
Introverted, sporty, musician, gamer, and used to love to read a lot.
A little awkward, athletic, fun-loving, and a good friend.
Shy, 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 shy.
More recently, the team I'm leading, we work with a lot of robotic sensors. Sometimes these sensors don't work, or the robotic equipment doesn't work as expected. And my team helps us understand what went wrong with those sensors and how can we ensure that they never have those same problems again.
As a research scientist, I develop innovative physical items and physics simulations, kind of like video games, to be able to solve robotics problems in our fulfillment centers. What that looks like is getting robot arms to reach into shelves, pick up items, and then those get routed around a fulfillment center to get to the package that arrives at your doorstep.
As the head of the Solutions Design team, I get to innovate with my team on next generation solutions technology that will help Amazon ship globally in our one-day delivery windows.
I really love the way in which robotics is a fusion of a number of different principles and disciplines. So there's mechanical engineering, electrical engineering, software engineering, all coming together to just kind of create this super cool device.
Most people who work in software, they see something on a screen or a computer, but when we write some code, we actually see the physical robot do something, which is very cool to watch.
I would encourage students to get into careers in tech if they want to make a difference in society and get to work on technology that society uses every day to help advance our lives.
Tech is a field that is constantly changing and constantly evolving. And so if you work in tech, you're going to be working on problems that just evolve and change, and you'll likely never get bored. My friends and my family all get Amazon packages, and I get to see how the work that I do impacts a lot of different people, and I think that can just be really rewarding and fun.
Those are just some of the many engineers at Amazon that make our fulfillment system possible. Of the engineering careers you saw, which careers interest you the most?
Got that. For those of you that tuned in to meet those three different engineers that work behind the scenes on our robotics for the Fulfillment Center, which is most interesting to you? Where could you see yourself in the future working in robotics, designing and building robots, coding the robots, the software that's in them, designing the whole process, or helping troubleshoot when things go wrong? Yeah. We get lots of folks interested in designing and building robots. All of these jobs are needed to make the Fulfillment Center robotics work, to deliver packages. So hopefully one of these roles might be interesting to you in the future. We're going to close it out.
No matter what you chose,
one last video.
There's something for everybody in technology and engineering. Well, everyone, that concludes our tour. Tour leaders, can you join me to say goodbye? Bye.
All right. Thank you all so much for coming along that tour with me. I really want to make sure that teachers in the room first, if you have other students that weren't able to join you today, please know that this virtual tour is available on Kahoot. You can find it at our website, amazonfutureengineer.com. And you could also go on Kahoot and search it up. So we have the Kahoot tour ready for you to play in your classroom. I am now available if anyone that is still here, if your class period hasn't ended yet, please let me know, what questions do you have about this tour? Or since I'm here, if you have questions for me about my job or what it's like to work at Amazon, I'm happy to answer those as well.
And Nicole, it looks like we had one question come in, and they are asking, what is the cloud? I know they talked a lot about what the cloud is, but if you could talk a little bit more about what the cloud is.
Super awesome question, and thank you for asking it. I was much older than you were when I had the same question. I didn't know. I just learned what the cloud was not too long ago. So the cloud is essentially a whole bunch of servers or computers that are accessible by internet, so that you can use your local computer or phone or device to connect to the other computers that are in the warehouses, essentially, through the internet, and you can access data or software that are running on those computers. So that's what the cloud is. Yeah. Good question. How long does it take to put one's order together? I don't actually have the answer to that question, but we do know, if you recall from one of the very first trivia questions, that the fastest order ever delivered on record was just under 30 minutes from the time it was ordered to the time it was delivered. So you have to imagine that putting an order together is pretty fast. I will say that my personal favorite part of the tour is when they put that GoPro camera in one of the totes and zoom us through the conveyor belt system. Like that just tells you they are working as hard as possible in those fulfillment centers to do things the fastest way possible. Any other questions?
Looks like we have another one. How many packages does an Amazon worker see daily?
Oh gosh, I think that's a great question. I don't have an answer to that one either. I wonder what you think. How many packages do you think an Amazon worker would see daily? And I assume you mean an Amazon worker who's in the fulfillment center, right? So if they're doing if they're like in the picking, they probably don't see a lot of Amazon packages, but if they work in packing, they probably see the most, right? Because they're just packing and packing and packing those boxes. And I think that, you know, if you are packing a lot of items in one box, you'd see fewer packages. If you're packing big items, you know, Amazon ships really big items. You can like get furniture from Amazon, so that you might see actually less. So it's really hard to calculate the average number of packages someone sees. Oh, what college degree did I go for? That's a great question. My particular pathway is not in computer science. It's not what I studied initially. Although I did think it was really interesting. I took one class in coding when I was in college. I went to University of Michigan. I was the first generation in my family to go to college. And I actually studied biopsychology, which is in the sciences. But I didn't really understand what I wanted to do when I went to college. I think that's common for a lot of first generation college students. So I just kind of took classes that were interesting to me. And it wasn't until after I finished my college degree that I started really discovering what my passion was. And truthfully, I worked in education for a long time, for about 10 years before I pivoted into education technology. And then it's on the job that I've done a lot of my learning about how products are built, how coding works, and how different parts of the process of developing software have to fit together in order to get a product built on time. So for which positions do you need a college degree for? Excellent question. I think that, I always recommend pursuing college. In fact, I'm going to take a moment to plug Amazon has, I should just pull it up right here. If any of you are seniors this year, we've just opened up our scholarship application. So Amazon Future Engineer gives away, I think, over 400 college scholarships every year to high school seniors who want to pursue computer science or hardware engineering. So that includes the robotics field. The minimum GPA is 2.3. I think that's about right. And the scholarship is an incredible opportunity. It's a $40,000 scholarship, but more than that, it comes with a guaranteed internship at Amazon between your freshman and sophomore year of college. So you get not only money to support your tuition and expenses for college, but an opportunity to come work at Amazon for a summer. It is a very well-paid internship, so that's awesome. You do not need a college degree for every job at Amazon, and not even for all the high-paying jobs. There are lots of pathways that you can take to learn how to do coding, if that's what you want to do. But if you want to do deeper computer science, it's likely that you'd want to pursue a college degree. And Amazon has a lot of programs available for employees who work even starting within our fulfillment centers to help further education and to learn and transition to different careers within Amazon. So there you go. Cool. I hope that answers your question. I think that a college degree, if you can do that right out of high school, is a really great option. It will give you the best chances at getting into an engineering career more quickly, but it's not the only pathway. So don't be discouraged if college is not your best option right out of high school. Even community college is great. We have lots of Amazonians that started with community college or that didn't even pursue college right away, but later, after years of working in other places, came back to further their education either at a college or through programs for learning coding and things like that. How long did it take to develop the process, the warehouse programming? Ugh, great question. And it feels like a trick question to me, friends, because the process is always evolving. We are constantly innovating and improving. And in fact, there are people that work exactly at that, looking at how things are and how to improve it. And it's called a process engineer or process improvement. So it's a very cool field. So how long did it take? I'll let you know if we ever finish developing the process, because it takes forever and ever. We'll be working on it. Oh, and the symbols on my shirt. You probably saw a lot of the folks on the tour wearing our same Amazon Future Engineer shirts. These are symbols that are used in software coding languages. So we just like to wear it to feel kind of cool. We like software coding in different programming languages. Oh, have I caught up on all the questions? You all really threw them in there for me, so thank you so much. Here's 3 questions that people always ask me on these tours and in any kind of meet and greets for Amazon. First, have I ever met Jeff Bezos? No, I have not. I don't think that I think it's highly unlikely that I ever will. Amazon is very, very, very big. We have about 1.5 million employees. That's huge. So I don't even live in the same city as Jeff Bezos. I'm actually dialing in here on Zoom from San Diego, California, to see you all in Albuquerque and surrounding areas in New Mexico. Second question, does Amazon use drones? People always ask me that. When will I get a drone delivery? I mean, Amazon's exploring the use of drones. And I think if you go on the internet on Google and search up Amazon drone deliveries, you'll see that we actually have a design for one. And we are doing some very early testing of drone deliveries. And that's all I really know about it. I wish I could tell you more. Oh, one more question in. How do you come up with QR codes that robots use to move around with? Good question. Somebody invented that, right? I think someone figured out that barcodes and QR codes would be a really quick way, using that sensor technology to read information. So the sensor reads that QR code, and that is actually a path to the internet in the cloud to retrieve information associated with that QR code. So how to come up with it, that is just part of the invention and engineering process. I was not involved with inventing QR codes at all, so I can't tell you how that particular invention came about, but I know that lots of great inventions start with thinking about problems that need to get solved or how to do things differently, faster, easier, with less resources or with less energy, and just some really creative thinking and then engineering. All right, I have time for probably just a couple more questions in here. When did you start the warehouse program process? I'm not sure I fully understand that question, but you'll know Amazon has been around for a long, long time. And actually, I wonder if any of you know how Amazon got started, because Amazon did not start as this idea of having all of these big fulfillment centers and selling every product under the sun and shipping it really quickly. Does anyone know? Amazon started by selling books. That's right. Our founder realized that books were a good market and that there was a market for reselling used books. So started a website to be able to sell used books, and it just evolved and evolved into this. So thank you all so much for joining. I want to make sure that you all saw our website here is amazonfutureengineer.com. Teachers, hopefully those of you that have registered, you'll get a follow-up email because we would love to offer you as a teacher, if you dialed in with your classroom, a swag pack to say thank you for joining us on this tour. So it will involve a little bit of swag for your students in your classrooms, and that will be in a follow-up email. So thank you so much for joining us. I'm Nicole with Amazon Future Engineer. Sebastian, thank you for this opportunity. I love that I got to connect with students in New Mexico. How cool is that? You all rock.
No, thank you so much, Nicole. If we were all in a room, I'm sure everybody would be clapping for you. And actually,
yeah, we'd just high five everywhere. Yay!
And I know you guys will be here in Albuquerque, all the way from California, right, on Friday. So
yeah, that's right. That's right. Oh my God, one of my favorite people ever from Amazon, Luna Martinez, she will be there on Friday live. She will do this tour in the big room at the conference in person on Friday too.
Fantastic. So I encourage any teacher that's on here, classrooms, I think Highland High School is actually on today, to come in and join us on Friday from 9 to 3 at the Expo New Mexico Manuel Lujan building. We're really looking forward to it. Want to give a big thank you to all our sponsors, especially Honeywell, who is our title sponsor for this event, and folks like Amazon, who take the time to promote STEM learning and education and hands-on activities to our students here in New Mexico. So I hope you guys enjoyed this, and we'll see you. There's going to be a few more virtual presentations before the in-person event. So go on our website, discoveryfestnm.org, to learn more about upcoming virtual exhibits. And hopefully we'll see a lot of you on Friday. So thank you so much for your time. Thank you again, Nicole. You're awesome.
Thank you all.